Welcome to VeeBee Coding. You can call me Bee. In today's video, we'll be going over how to do some encryption in our SQL server. We'll go over some definitions, including the certificate, what a symmetric key is, and different algorithm types. We will go over how to encrypt data that's already in a table, how to decrypt data so we can view it, and when we're inserting rows, what the information looks like if you're just inserting without the encryption and then insert it with encryption. And lastly, create a store procedure to more easily handle pulling that information, which includes opening the key, doing your selects, and closing the key again. A few quick definitions that I will leave on the screen. These are taken from Microsoft. So a certificate is a security object that contains a public and optionally private key for SQL Server. There are different types of encryption keys. You can have a symmetric key where the same password is used to both encrypt and decrypt the data. You can have an asymmetric key where a different key is used for encrypting versus decrypting the information. And lastly, the database master key is a symmetric key that's used to protect the private keys of certificates and asymmetric keys. I will share the links to these screens down below in the description. So starting off with creating a master key. If you don't have one already, go ahead and create master key with the encryption set to a desired password. After that, you can create a certificate and give it a name. And leave a descriptive subject so you know what the certificate is going to be used for. And then you can create a symmetric key that you will use to encrypt your data. And that symmetric key will be encrypted by the certificate that you just made. So to encrypt data that is already in your table, you first need to open the symmetric key, and then you can do your update. So basically, we are going to take the original information of that column and then surround it by encrypt by key and reference the key GUID from that symmetric key. And after the update, you close the symmetric key at the end. If you wish to view the information, then you need to open the key again. Then you can do your selects and decrypt it, and then close the key again. And you would execute this full script top to bottom all at once, and then you can view the information. If you are inserting additional data into your table and you want to encrypt the data as you are inserting, then you would surround the key information. In this case, we are working with fake social security numbers. Instead of just giving it the number, we are going to surround all of it with parentheses. Start it with encrypt by key. Specify key GUID. And you want to use the key from the symmetric key that you create at the start of this tutorial. But what if you think that some data was inserted into the table later on and it was not encrypted? Is there an easier way to see which rows are not encrypted, and so you can do an update later on to make them encrypted? So you can make a view for this, but you do need to make it in multiple parts. So on previous slides, you saw where we opened the key, we did our select or update, and then we closed the key. In those previous slides, you would have highlighted everything from open symmetric key all the way through to close and execute all at once. In this case, when you're creating a view, you want to first highlight and execute the open symmetric key, and then highlight and execute the create view script. And after that, highlight and execute the close symmetric key. So a quick explanation of this select here and how it works. I have my base table. In this case, I have a data collections team table where I have some employees, some surveyors. And so I have that raw table doing a join on that same table again, but we are decrypting the social security number. So once we make a join on the original table versus our decrypted version of the table, we have this case statement that sees, does the value from the original table not match the value of the decrypted version? And so if the values don't match, then that means that the original data is encrypted. If both values match, meaning there's no difference whether the data is encrypted or decrypted or not, if they are exactly the same, then that means that the information is not encrypted. So we are leaving a comment of not encrypted in our column called encrypted check. And later on, we can reference this view for an update to update those specific rows. So on the previous slide, we made this view right here, the VW data collection team not encrypted. So now we can do our open symmetric key, do our update, set the social security number column equal the social security value, but this time encrypted. And in our table, we have a comment column. So I'm going to keep notes saying I edited this value. It is now encrypted, just for our tracking. And you would highlight and execute this whole script top to bottom. We will go over, again, viewing the information decrypted. You have to open the key, do your select, close the key. But the whole script you see in the middle here, but that can be a little bit too much, especially for, let's say, you have other information, other team members who focus on creating reports like Power BI reports, and maybe they're not SQL people, so they're not comfortable working with this. You can make a store procedure that does all of that for them. So then when they go to grab data for their Power BI, all they need is this execute and then the store procedure name. It's much more user friendly. So here, when your reporting team goes into Power BI, they would enter in the SQL Server name, the database name, and when it comes to the data connectivity mode, choose imports. And then down in the SQL statement, that is where they would put the execute and then store procedure name. If they do click on direct query, then after they insert this information, hit OK, Power BI will look like it's going to grab the data, but then ultimately the user will receive this error message of incorrect syntax near keyword execute. So make sure that you are using the import connectivity mode at the center there. And just a quick bonus note, if you want to change your master key, again, this is what is protecting the keys for your certificates. You can do alter master key regenerate with encryption by password, and then give it a password. And then this is going to update that key GUID column. And you'll see this when we get started in the tutorial. And let's hop over to SQL Server. So I'm already logged into SQL Server. To get started, we want to create a work table that we can work with. So I'm going to create my data collections team table, including just the employee ID, name, what their title is, a social security number, and a comment. So I just highlight all this, execute. And so if I look at my tables, if you don't see it, don't forget to click on the refresh button at the top, and then you'll be able to see new tables down below. So we have this empty table. We need to put information in it. So let's start off with just a simple insert. 3 rows in. So we just added Jane Doe, Bob Green, Ashley Johnson. These are all fake people, fake employees, fake social security numbers to work from. If you are following along, all code will be posted on GitHub. So you can just copy paste there. Now that our table has information, now we can create our certificate. Again, this is a security object that contains your keys. So if you have not already created a master key, go ahead and do so. I've already created this, so that's why I'm getting an error. So going down to our next step, we want to create our certificate. And to do so, we'll do create certificate. I'm going to call it VeeBee cert with subject VeeBee certificate. Highlight, execute. It is completed. And now we have our master key, we have our certificate. So next up, let's create a symmetric key. And this is going to be protected by the certificate. So to do this, do create symmetric key, give it a name, VeeBee symmetric key with algorithm AES 256. Encryption by certificate. VeeBee cert. This is the same certificate name that we just put up there. Now highlight, execute. There is another way to create symmetric keys. So this is encryption by certificate. Another way to do this is encryption by password. But for the rest of this video, I'm going to be continuing with the encryption by certificate. But just to show you a second method. Okay, so I'm actually going to get rid of this so it does not confuse anybody. And I like to put in these breaks in my code just to help section things off, make it easier for my notes. A quick note that I copied ahead of time. So while looking at this algorithm, what does AES stand for? What is the 256? What is that? Right here in the middle. So AES is Advanced Encryption Standard. So basically, the different numbers mean the length of the encryption key. So you can have AES 128, 192, 256. So the bigger the number, the more secure it is. But maybe it can affect performance. So here, let me make sure you can read it all. So AES 128 is the fastest. AES 256 can have slower performance. So 192 is like the happy middle ground. But because in my table I'm working with social security numbers, I want the highest security. So that is why I chose 256 for my algorithm. Okay? So what if you want to view list of keys in there, encryption, algorithm, description. Do select star from sys.symmetric keys. Highlight, execute. So now you can see the different keys in your database. You can see the algorithm description. Here's that name that we gave our key. And you can view the key GUID. And a quick note, the GUID is the globally unique identifier. So that's what that stands for. Another break in our notes. Continuing on. Next step. So we have our certificate, we have our symmetric key. Now it is time to start using it to encrypt our data. So encrypt existing data in current table. So to do this, first we need to open our key. The decryption is done by the certificate, VeeBee cert. Update. Our table name is data collection team table. We want to set our social security column equal to still the SSN column, but we want to now encrypt it. So encrypt by key GUID. Here, just not to confuse myself. Using our symmetric key that we made earlier. And then we have to close that key again. To complete this, highlight the entire thing, all the way from open the key, through the update, and all the way through close symmetric key. Execute. And you might see this error about data will be truncated, and that's because of the length of my social security column. So just to make it easy, I'm just going to alter my table, alter that column, so the length is now 100, which might be a bit overkill, but this is to help accommodate the key GUID being used or reference. So now if I go back to my encrypt existing data, I can go back to open the key, update, close it. So now I have 3 rows affected. Now that we've made that update, let's view the table. So now all of those social security numbers are no longer visible. So now if somebody wants to see that information, now they need to be privy to the symmetric key that was used. They need to know the certificate that was used. So viewing the decrypted data, you need to have the full open symmetric key, decrypt by certificate, VeeBee cert, do your select, and while you're doing the select, you need to be decrypting it, and then close the symmetric key again. Highlight the entire thing top to bottom, and now you can view the information again. So now that we have gone over encrypting existing data, let's take a look at how things look if additional data is added to that table. So this is going to be our insert additional rows notes. First, we are going to do inserted without encryption, just to see what it looks like. So I just have another basic insert, and for my comment column, I have a quick note saying I'm doing this insert without encryption. So let's view what this table looks like. So you see the old rows are still hidden, but the new rows, the social security numbers are visible. So that was inserting without encryption. Let's do another insert, but this time let's do insert the data with encryption. So I'm going to do the same, open symmetric key, decryption by certificate, do the insert, and the only difference is instead of just giving it the social security number, I am surrounding that social security number with parentheses, including encrypt by key, reference the key GUID from the symmetric key that we made. And at the end, for our comment column, I'm leaving the comment saying I'm inserting this information with encryption. So I'm going to highlight all of this, execute, 3 rows affected. And just to keep the information flowing, I'm just copying that same select down below. How does this look? So the data that was inserted with encryption looks the same as the data that we encrypted before. So this is nice. So out of curiosity, what if you try viewing the data decrypted? So you would think that you would be able to see all the information, right? Well, let's take a look. So see how it looks. So records entered without encryption are actually going to show as null. Records added with encryption will show their value if we do our select with the decryption. So I'm going to do the same, open the key, do our select. We are converting our social security column to be decrypted, and close the key again. So notice that those rows where the values were not decrypted, it's like if you're trying to decrypt something that's not even encrypted in the first place, you just get nulls here. So we want to make sure all of our information is encrypted, not only for just the security, but also when you're going to go backwards and view the information, you don't want to not be missing something during your review. So now we're going to go back and encrypt these rows for our employees with the employee numbers 22221, 2, and 3. So here's method 1, doing the update based off of hard coding, where I'm specifically calling out the employee IDs. You can certainly do this. 3 rows affected. I'm going to scroll back up so we can view everything. All rows look good. And even if I go back and view the raw data, not decrypting, everything is showing as, well, everything's just not showing, which is good. That's what we wanted. But this is based off of hard coding. There are better methods to do your updates because you don't want to accidentally miss something. So we can, 2 other methods. One is create a work table. A second method is create a view. And then the update can reference the work table or view for mass updates. So I'm going to reinsert rows that are not encrypted so we can test. And I just like to keep copying that select star just so we can just keep tabs on everything. Here's our new rows where the data is not encrypted. So now let's create our work table. So basically, here if I comment that back out. So basically what this select is doing is, well, we have talked about this when going over the PowerPoint slides. It is looking over the raw table on its own and doing a join back on that table, but now the values are decrypted. And then we are comparing that raw social security number value from the original table versus the decrypted version of that social security number. And if they're different, then that means that the value is encrypted. But if the value is the same, if the raw number from the original table matches the the quote-unquote decrypted value from your join, then it's not encrypted. There's no difference between the two. So then for our case statement, we're saying it's not encrypted, and our column name, we are just calling it encrypted check. And so to create a work table very quick, you just write your selects, and above your from section, just say into, and then give it a name. So I'm doing my select into work table, yada yada. WK standing for work table. And then you continue from such and such. Highlight the entire thing and execute. 12 rows affected. So now let's check out our new work table. Viewing the entire thing. Here's how the whole thing looks. We can see the social security value from the original raw table and the social security decrypted version from our join. Because these two columns are different, I know that this value is not encrypted. Because because this has a value and this is null, actually our comparison, it's not necessary that these were the same, but these are null. Our query knew that these rows were not encrypted, so they were marked accordingly. And you can add in a where clause, so you can just narrow down just on those records. So now that we have a work table, we can do a new update. So we are going to do our normal open Symmetric Key, update our data collection team table. But then down below, we are going to say from that same table that we're updating, do we inner join on the work table where the employee IDs match, but we only want the update to happen if the column that we called encrypted check states not encrypted. So we only make updates that need to happen. And this is nice where, because we are updating from a work table and not hard coding any employee IDs, you're not going to accidentally update somebody that shouldn't have happened. Well, they would be encrypted. In this case, it wouldn't matter too much. They'd be encrypted anyway. But you're also making sure that you're not missing anybody. So 3 rows affected, check out our work table. Social security numbers, everything should be hidden. And they are. And also when we made this update based off of the work table, we updated the comment column to keep the original comment, but also add to it, adding in front of it, the comment. We edited it. It is now encrypted based off of the work table, so that you can keep a audit trail this way. So also double checking, viewing that work table decrypted. Everything still looks good. So one more way to do your update. We did update based off hard coding, giving it specific employee IDs. We did an update based off of a work table. Now let's do an update based off of a view. So let's get information back in there that's not encrypted, so we have something to work with. So we have 3 new rows at the very bottom. So now when we create a view for this kind of project, we need to do it in 3 parts. So part 1, open the key. So highlight this top part and execute. The second part is creating the view. Let me uncomment these. And you'll notice this is the same select that we used before to make our work table. Again, we are looking at the raw, not decrypted table, comparing it to the same table but decrypted, and making our comparison between those raw social security numbers and decrypted social security numbers. If they match or don't, that helps us know if they are encrypted or not. So we've already opened the Symmetric Key. So now let's highlight and execute our create view. You can see commands completed successfully down at the bottom. Our view is created. So now step 3 is closing the key. All good. So now let's take a look at that view, see how it looks. So if we look at the view like this. Yeah, if we look at the view just raw, you get a lot of noise. And what's funny enough is that the encrypted check doesn't quite work on its own here. But once you open the key, let it run, and close the key, the results correctly narrow down to just what needs to be updated. Okay, so now we have a view to work from. So now we're going to do the same thing that we did before, update our key, do our updates, still doing the same thing, joining our core data collection team table, doing an inner join with that view that we just made, but we only care when the encrypted check column says not encrypted. So highlight the entire thing, execute, and you'll see it just says only 3 rows were affected. So again, it correctly identified that there were only 3 rows that needed to be updated. So let's view our data again. This is just the open key. Do your select, decrypt the values, close the key. All of the social security numbers are showing correctly. Versus if you view the raw information without the keys, everything is correctly hidden. So that is good. Add another break in our notes. But what if somebody else needs to have this? Let me get this aligned right. So now what if somebody needs to build a Power BI report based off of this information? You could supply them with all of this, but maybe they are not comfortable with SQL. They don't like working with all of this. You can put this in a store procedure, so it does it for them. So let's do create stored procedure to open key, decrypt the values, and close the key again. So to start off, do create procedure. I'm going to start off the name of my store procedure with SP for store procedure. So SP master data collection team as, and I'm just going to grab the same script that we've been running multiple times in this video, paste it down here, and just make it easier to read, indent it a bit, go. Highlight the entire thing, execute. Actually, I already made this store procedure before. So it already exists. So for fun, if you want to test your store procedure, you just do execute and then type in the same name that you gave it up above. So execute, and there you go. So instead of having to run and execute this entire thing, all you need is that one line. So for our final step in this tutorial, let's quickly go over the Power BI side. So now that we are in Power BI, to get the information in here, just go to Data, SQL Server, enter the server name and database name. In my case, my server name is this coffee / SQL Express, so I'm going to put that name here, and I'll put in my VeeBee tutorials prod in the database name, Then V tutorials prod. I'm going to leave the connectivity mode as import. And then for the SQL statement, I'm going to put in my execute and then the store procedure name and hit OK. And go ahead and hit load. There you go, there's your data source up there. So now you can create your table, start adding in all of your information. Make it big enough to read. And there you go. And then you can also have your Power BI published in a specific workspace where you can monitor, or you can only allow certain people access to the workspace. So continue to be mindful of the security and what information you are working with. And there you have it. Hello. Thank you so much for watching. If you have a scenario in mind, feel free to email me at askvbcoding@gmail.com and I'll consider them for future videos. I really appreciate your time and thank you again for watching. Have an awesome night. Goodbye.